heart is the most essential organ in the body. It acts as a pump that delivers blood to the rest of the body, so its functionality is crucial to survival. The heart has 4 valves that ensure that blood flows in the correct direction. However, due to certain heart diseases or even just from old age, the function of this valve, called the mitral valve, may begin to deteriorate, causing blood to flow backwards, which is called mitral regurgitation. This is the most common valvular disease, affecting nearly 6 million people in the United States, and many of these cases necessitate valve replacement. Currently, in mitral valve replacement procedures, a prosthesis for the aortic valve is used, which has many significant anatomical differences. Not only is the mitral valve much bigger than the aortic valve, it is a D shape rather than round. Additionally, the native aortic anatomy has calcification that the mitral anatomy lacks, further contributing to the instability of this prosthesis in the mitral valve. To solve this problem, we present the MitrAffix. This is a stent that will act as a universal adapter for transcatheter aortic replacement valve use in the mitral position, regardless of annular size or shape. It flares into the left atrium and ventricle to ensure a secure fit in the mitral valve. It has a rigid, narrow waist that mimics the size and calcification of the aortic valve. This narrow waist also bypasses the variability of the mitral annular anatomy. The MitrAffix also has a polyethylene terephthalate cover that will redirect blood flow through the new valve and prevent leakage. This polymer cover will be coated in proteins that will promote endothelial cell growth around the MitrAffix, integrating the device into the heart wall and further improving its stability. Currently, transcatheter mitral valve replacement is only available for MR patients who have failing bioprosthesis from a previous open heart mitral valve surgery. However, 50% of MR patients are denied surgical repair and replacement of the mitral valve due to high risk. Because the MitrAffix would act as an adapter for transcatheter replacement of the native mitral valve, we project that the MitrAffix could nearly double the number of MR patients eligible for TMVR. The market potential for global TMVR shows a compound annual growth rate of 15.1% between 2024 and 2031, which comes out to a total of $17.5 billion. Simply put, no current product effectively secures a TAVR valve in the mitral position regardless of annular size or shape. MitrAffix fills this critical void, enabling replacement instead of repair and unlocking life-saving treatment for a broader range of patients. We believe that our device could revolutionize mitral regurgitation care. With MitrAffix, we're not just improving outcomes, we are expanding possibilities.